at Team at Class. In this live class, we want to look at this topic in mathematics, which is matrices and determinants. So we look at matrices and determinants. We started this topic in our previous live class, and we looked at some of the things which are important under this topic. So we started by looking at what matrices is, the definition of a matrix. So we look at the definition, we look at the order of a matrix, we look at notation of a matrix, we look at the types of matrices, we look at addition and subtraction of matrices. Also, we looked at scalar multiplication. Scalar multiplication, of matrices. Also, we looked at multiplication of matrices. So this is where we stop. You can check our previous live class to watch all this. Thank you. Now, in this class, let's start from this multiplication of matrices. So we want to look at an example here. So we want to multiply given two matrices. So let's look at this example. We have let A be equals to, or given that A equals to a 2 by 2 matrix 1 3 2 minus 1, B equals to, we have 2 by 3, that's 2 0 minus 4, 3 minus 2 6, and C equals to, we have, C, and C we have also 2 by 3, that's 1 2 0 3 4 minus 2. Then the first question said compute the following. We have the first one, A times B. The second one, we have B times A. The third one, we have A times B plus C. Now, let's look at the solution of this one after the other. Like the first one here, A times B. A first and B second. A multiplied by B. Then here, we write A first. That is this will become, this is matrix A, and we have A, that's 1 3 2 minus 1 times B, and B we have 2 0 minus 4 3 minus 2 6. Now let's check the order of this matrix. This matrix has an order of 2 by 2. So 2 by 2 multiplying by, we have this as 2 by 3. This is row by column. So 2 rows, 2 columns here. 2 rows, 3 columns here. Now, continue with this multiplication, and the result will give us 2 by 3 matrix. So this is the result. Then let's now multiply. Let's multiply here. Then we use the first matrix to multiply this other one. The row. This row here, we multiply each of these column. Then for the first column, this row multiply the first column. The first element multiply the first element. 1 times 2, that's 2. Then plus, we had it. 3 times 3, that's 9. So we are done with this column. Also use the same row to multiply this column. That means we leave a space. We have 1 times 0, that's 0, and plus 3 times minus 2, that gives us minus 6. So we are done with this column as well. We are still on this row. Use the same row to multiply this. So 1 times minus 4, that's still minus 4, then plus 3 times 6, that's 18. Then we are done with that particular row. Now move to the second row. Use that same row to handle these 3 columns. But this here we have 2 times 2, that's 4, then plus minus 1 times 3, minus 3. So we are done with this. See, use the same row to multiply this column. 2 times 0, that's 0, plus minus 1 times minus 2, that's plus 2. Then we are done with this column. Also use the same row for this column. So we have 2 times minus 4, that's minus 8, then plus minus 1 times 6, that's minus 6. So we have this. You are watching us live here at Master T Math class. Do it to stay tuned and share this video. Also give it a thumbs up and subscribe so as not to miss out on our videos. Now when we write the final answer here, this becomes 2 plus 9, that's 11. Then 0, this becomes minus. Anytime we have plus minus, different sign to be minus. So 0 minus 6, that's minus 6. Okay. Then minus 4 plus 18, same thing as 18 minus 4, that's 14. Then here, you also minus, that's 4 minus 3, that's 1. 0 plus 2, 2. Minus 8 minus 6, this becomes minus, plus minus become minus. So minus 8 minus 6, that becomes minus 14. That is, here we have the result of A times B as this 2 by 3 matrix. So that's what we have for the first one. Now let's compute the second one, which is B times A here. That means B is coming first. Next now. For number 2, B come next, B come first. As this here, we are going to have B times A. Then we'll be writing B first. B we have 2, 0, minus 4, 3, minus 2, 6 times A. And here we have 1, 3, 2 minus 1. Okay, that's B times A. Now check this. For us to continue, we need to check if this multiplication will be possible. So we discover that this order here, we have 2 by 3. That's 2 rows and 3 columns. Then multiplying by, here we have 2 by 2. And for us to confirm, we check the column of the first matrix and the row of the second matrix. Are they the same? So these are not the same, not same. This is 3, this is 2. So therefore, we conclude that B times A is not possible. So we can multiply this type of matrix. Once the column of the first matrix is not the same as the row of the second matrix, it implies that this multiplication is not possible. Then we move to the next one, which is number C here. Third question. C. Now, when we have something, we need to handle the bracket first. And what is in the bracket, which is B plus C? We had B and C. So we have 2, that's B is 2, 0 minus 4. Then 3 minus 2, 6. Then plus C. And C here we have 1, 2, 0, 3, 4 minus 2. So here we just add the corresponding elements of these matrices. And this, the first and plus the first. So 2 plus 1. Here we have 3. 0 plus 2 is still 2. Minus 4 plus 0, still minus 4. 3 plus 3, that's 6. Minus 2 plus 4, that's 2. 6 plus minus, that's 6 minus 2, this is 4. So this is the result for B plus C. Then we can now multiply this by A now. So when we write, let's just write this result here. That is B plus C. We got that to be 3, 2 minus 4, 6, 2, 4. Then we can now multiply, use it multiply A. So that when we check that out, okay, so now when we check the order of this matrix, A is a 2 by 2 matrix, and multiplying by the order of matrix B, that's a 2 by 3 matrix. So to know whether this multiplication is possible, the column of the first matrix and the row of the second matrix must have the same number. So this have the same number. So we can go ahead and the result will give us a 2 by 3 matrix. So now let's multiply here. So we use the first matrix, the first row will multiply these 3 columns. So the first row, 1, 3 here. So multiplying this first column, 1 times 3, that will give us 3, then plus 3 times 6, that's 18. So the first number multiplying the first, the second multiplying the second. Now leave a space and use the same rule for this column as well. So 1 times 2, that's 2, plus 3 times 2, that gives us 6. Also, use it for the next column. 1 times minus 4, minus 4, then plus 3 times 4, that's 12. Then 6, that's minus 6. We are done with this column. Also, the same rule, use it for this column. 2 times 2, 4, plus minus 1 times 2, minus 2. Then 2 times minus 4, minus 8. Then plus minus 1 times 4, minus 4. So we have this. By the time we find this, simplifying this, 3 plus 18, that gives us 21. 2 plus 6, 8. Minus 4 plus 12, that's still 8. That's like we have 12 minus 4. Then here, 6 minus 6, because plus minus become minus. So 6 minus 6 is 0. This also is minus now. 4 minus 2, that's 2. Minus 8 minus 4. This also become minus. So minus 8 minus 4, that's minus 12. So we have also a 2 by 3 matrix here. So that is the solution to this particular problem on multiplication of matrices. Welcome one more time to Master T Math class. Thank you for connecting. So do it to stay tuned and give a thumbs up and share this video. Now we move to transpose of a matrix. So when we hear the word transpose, what does transpose mean? So we have what is called transpose of a matrix. Now, the word transpose simply means interchanging the row and column. So when we hear transpose, it's simply interchanging of row and column. Interchanging the rows. Oh, okay. So welcome back to this live transmission. So we talk about transpose of a matrix, and we discovered that transpose of a matrix simply means that we interchange the rows and columns. So the row and column of that matrix will be interchanged. And if we have a matrix A, the transpose of A is denoted as A raised to power T. So the transpose means the row will change to column and column will change to row. Okay? And it is denoted as A transpose. So if the matrix is A, transpose of A is A transpose. And generally, if the order of A is n by n, okay, the order of A transpose will now be n by n. That is, the row here not serving as a and the column here is serving as 0. Now, when we look at this example, we have matrix A. Let matrix A be this 2 by 3 matrix, that is 2 rows and 3 columns. We have 3, 2, 1, 4, 2 minus 1. Then find A transpose. Okay, so A transpose here means we are going to interchange the row of A now. The first row will now serve as the first column. That is, here, the first row we have 3, 2, 1. Instead of writing it as a row now, we are going to write it as a column. So that's why we have 3, 2, 1 here as a column. And also the second row, which is 4, 2 minus 1. Here we are going to interchange that also as a second column. So we are going to write it vertically. That's why we have 4, 2 minus 1. So it's now having 3 rows and 2 columns. So now we have a 3 by 2 matrix. All right, now let's consider another thing here. Okay, let's consider determinants. Determinant of 2 by 2 matrices. So we have